Let's move on to one of the most important results in this section, the extreme value theorem. The theorem says, if a function is continuous on a closed and bounded interval from a to b, including both endpoints, then the function must have an absolute maximum and an absolute minimum somewhere in that interval. Let me say that again in simpler terms. If your function is continuous, meaning there's no breaks, no holes, or no jumps, and defined on a closed and bounded interval, meaning it includes the endpoints, then you are guaranteed to have both a highest and a lowest point. This is really powerful because it tells us where extrema are guaranteed to exist. Let's look at these graphs to understand when the theorem works and when it doesn't. Here we have the graph of f of x equals x to the third on the interval from negative infinity to infinity. This function is continuous, but the interval is not bounded. It goes on forever, so there's no absolute maximum and no absolute minimum. Now we have the graph of the function f of x equals 1 over x squared plus 1. Again, all over real numbers. This is continuous, but not bounded. This function does have an absolute maximum of 1 at x equals 0, but it does not have an absolute minimum. It gets closer and closer to 0, but it never actually touches 0. So again, the theorem does not apply because the interval is not bounded. Here we have the graph of f of x equals cosine x over all real number. This function is continuous, but again, the interval is not bounded. We do get an absolute maximum of 1 and an absolute minimum of negative 1. But notice, these values happen at many different x values. So, even though the extrema exists, the theorem does not apply because the interval is infinite. Now, this one is interesting. This function is defined in pieces. Even though the interval looks closed, but the function is not continuous. There's a break. Because of that, there is an absolute maximum, but there's no absolute minimum. So again, the theorem fails because continuity is missing. Now, this is a perfect example where the theorem works. We have a continuous function on a closed interval from 1 to 4. So we'll guarantee both an absolute maximum and an absolute minimum. The absolute maximum is 4 at x equals 4, and absolute minimum is 0 at x equals 2. This is exactly what the theorem predicts. Finally, we have this function on the interval from 0 to 2. 0 is included, but 2 is not included. So the interval is not closed. Because of that, there's no absolute maximum. But there is an absolute minimum of 0 at x equals 0. So here's the big idea. The extreme value theorem only works when two conditions are met. First, the function is continuous. And second, the interval is closed and bounded. If either one of these is missing, then absolute extrema are not guaranteed.